All right, so now we're back to polynomials, and this time we're looking at the graphical behavior of the polynomials at the x-intercept. So if we look at this, where's the x-intercept? Well, where it crosses or touches that x-axis. All right, and what happens is the multiplicity, what we just learned about, determines the behavior of the graph at those x-intercepts. So a 0 with an odd multiplicity, so if you had a 1, a 3, or a 5, okay, so if your powers were 1, 3, 5, 7, etc., what happens is the graph crosses or intersects the x-axis. So as we see in this case, it's intersecting. Or if we have something, simple like this, you know, it's crossing the axis like that. Now, zeros with even multiplicity, the graphs touch or tangent to. Well, what happens there? Well, here, maybe it comes up and then it comes back down. It actually just touches it, and so that line then is tangent to it. Or maybe it's coming down here, and then we have a fat thing, but like that, but it's tangent at that point right there. Okay, so that's what happens when we have even multiplicities, and going through the graph could be odd. Now, of course, we could have a graph that looks like that as well. And different values are going to give us different multiplicities. Okay. And that's this next part. So if we give a graph of a polynomial function of degree n that identifies zeros and multiplicities, okay? And I think that's supposed to say given the graph, okay? Now, if the graph crosses the x-axis and appears almost linear at that 0, the multiplicity is going to be 1. And so if we think about that, that's what's going to happen here. It's just kind of almost straight across. It's just coming across that x-axis. So it looks sort of linear if we just look at it, just at a little spot here. So that would be multiplicity 1. Now, if the graph touches the x-axis and bounces off at the 0, the multiplicity is even, kind of like we talked about here. Now, depending on what the even number is, it's going to be more narrow or more wide. So the wider they are, the higher the multiplicity. And if the graph crosses the x-axis at the 0, the multiplicity is odd. So again, if it crosses, it's odd. When it was linear, it's an odd 1, but otherwise it's going to be an odd, 3, 5, 7, or something like that. So kind of something like this one, that's going to give us its crossing, but it's kind of got that curve in it. It's not a linear at that point, and so that's going to be 3 to whatever, depending on what we find. And then the nice thing is the sum of all your multiplicities is equal to n, okay? So if we take all these and add them together, we're going to get n, which is going to be the function's degree. So, if we have an x to the 5th, then if we have, a multiplicity of 1, a multiplicity 2, and a multiplicity of 2, 2 plus 2 plus 1 is equal to that 5, okay? All right, so let's use what we know now and kind of figure out what we know from here. We're going to find the zeros and their multiplicities at that 0. All right, so first we have to find that, and that. So let's say we have that first one looks like a -5, comma 0. The next one looks like a -1, comma 0. And the last one looks like it's a 3, comma 0. Okay. And that's just because that's where x was equal to, and when it hits the axis. Now we found the zeros. Now we want to find the multiplicities at that 0. All right, well, we know that it crosses like this, that's going to be odd, and these are both going to be even, okay? Now, since linear is a 1, let's assume that this looks pretty kind of narrow. It doesn't look like it's coming up and then going over and then coming back up again. It's pretty, curved here and curved here. So it looks like it might be more close to the, like that instead of the fat one. And so I'm going to say at the -5, the multiplicity is equal to 3, okay? Because that's the first odd. Then if I look at this one, that kind of looks pretty narrow too. And so what is the first even? Well, that's 2. So let's say our multiplicity here is 2. Well, 3 plus 2 is 5. I have to get to 9. Now, does being a 4 look right here? Well, that's pretty wide. That's not, it's not narrow like this one is. So multiplicity of 4 seems to fit. And so, I just took the 3 and the 2, which was the two smallest possible evens and odds, put those in, and then the leftover was 9 minus 5, which is 4. Then I looked at the 4. Does that make sense? Yeah, it's wider than the normal parabolic shape, and so I would say the 4 fits on that one. Okay. Now again, if we add all those together, what do we get? We get 9, which is what we were given as far as our degree of the polynomial. Okay. Now, if we're given a polynomial function, sometimes we have to sketch the graph, okay? So now we're going, instead of looking at the graph and saying, okay, what are the intercepts, what are the multiplicities and stuff, we have to actually sketch a graph. So first, we need to find the intercepts, both x and y, all right? Then we check for symmetry. If even function is symmetrical about the y-axis, so f of negative x equals f of x. And if it's odd function, it's symmetric about the origin, f of negative x equals negative f of x. And so that's key. So let's kind of write about what we have here. So if we have something that's coming like that, it's an even function, and it's going to be k is greater than 0. And if it comes down like this, it's also an even function, but k is less than 0. So we're kind of getting all the possibilities. And if you remember that one, that's an odd function, and k is greater than 0. And coming down like that, that was an odd function, and k was less than 0. So those are kind of the things we're looking at here. Then we're going to use the multiplicities of the 0 to determine the behavior at the x-intercepts. So remember, when it was odd and it went kind of like through the graph straight, then that was going to be the multiplicity was equal to 1. If it came down and touched, that was going to be even. And then if it came down and did something like that, that's going to be an odd again, but it's going to be, 3 or higher, depending on what it is. And this is going to be even, so it could be 2 or higher. All right. All right, so then we're going to determine the end behavior by examining the leading term. Okay, so these are end behaviors, so that's what it's going to look like based on that leading term. We're going to use the end behavior and the behavior at the intercepts then to sketch the graph. Now the turning points should be n minus 1 at max, so that's kind of a key thing to remember. And then, you know what? We can actually check this with technology to see, does our graph match what we said it was going to be? All right, so what do we have here? Well, we have x equals a negative 3 or a negative 3 comma 0. So we're going to have an intercept here. We're going to have x equals 2 or intercept at 2 comma 0. Now, if we plug in 0 here, 0 and a 0, so f of 0, that's going to give us our intercept for y. That's going to be 3 squared, which is 9, times a negative 2. So if we plug in 0 for x, we're going to get out a negative 18. So these are x-intercepts, and this is a y-intercept. And so we just plugged in 0 in here. We got out negative 18. We just solve those and set those equal to 0, and we have our x-intercept. So we have all that. The degree, well, we have 2 x's here, 1 x here. So n is equal to 3, so it's an odd. So what do we know? It's going to be one of these two. And what do we know about our leading term? Well, here it's going to be a positive 1, and it's going to be 1 squared, basically. And so it's 1, and this is times 1. So it looks like k is greater than 0, odd k greater than 0, so we know our end behavior is going to be something like that. All right, so now what do we do? Well, now we're kind of at the point where we need to start drawing something. Okay, so let's put our dots here. So let's call this our negative 3, 0. Then we have 1 at 2, 0. So that's going to be our other intercept. And then way down here at that's our 0, negative 18. That's what that point is. And so we know we have something that's going to look like this. So it's going to come up here and it's going to come down here. So how does that going to look? Well, at the x is negative 3, we have a multiplicity of 2. So that means it's going to be even. So it's going to come up to the graph and it's going to bounce off, okay? And this one has a multiplicity of 1, so that's going to go through the graph, all right? And it's going to be straight through, like this, okay? So let's just, like I said, draw this as we go. So we know it's coming down from here. We're going to hit up here and it's going to come back down. When it comes back down, it's probably going to come through here. Then it's going to come back up that way because we have our end behavior like that. So I'm thinking it's going to come up here, bounce off, come back down here, go through that intercept, and then come back and do something like that. And again, general sketch, that's all we can do here. You know, we're not plotting points, we're not doing anything else, we're just doing that general sketch. So now let's see if our graph looks like that if we do our calculator, all right? So plugging that in, we said it was x plus 3 squared times x minus 2 and no powers. And I don't know what the scale is here. We'll see if it graphs or looks good. All right, so it looks good. Comes up here, and that's going to be, what is our window here? By fives. So, you know, it's about 3, that's about 2, that looks good. Comes down here, that's going to be our negative 18. Now see, we had it flipping going through at 18, but it actually goes a little past, it looks like, and then goes up. So, you know, based on what we had, our best guess was it went through there and turned up, but it looks like it actually comes down a little beyond that and then it comes back up. Okay, so our sketch of our graph, it was good for what we knew, and so that's what I would say is okay. So let's go back. And so again, it was going to come down through here, go a little further, and then come back up. Okay, but again, what we knew is what we did. All right, what about this one? Okay, well, let's write our intercepts. So if we set that equal to 0, we're going to get 0, 0. If we set that equal to 0, we're going to get 1, 0. And we set that equal to 0, we're going to get a negative 3, 0. And guess what? They're all multiplicity of 1. So we're all multiplicity. Okay, so they're all 1s. What do we know else? So we have an x times an x times an x. So n is equal to 3. It's odd. Our leading thing here is a negative 2, so k is less than 0. So that means this time it's going to look like that. It's odd, so it has that shape. You know, it's either going to be like that or the other way. But because our k is less than 0, it's going to look something like that for our end behavior. So at the point we have right now, we know just that end behavior. We don't know what's going on in here, and that's going to be told by what's here. So let's draw what we have. All right, our points. So, well, we're going to have a 0, 0, so we'll have that point. We're going to have a 1, 0. Let's move it out a little bit further. So that's a 1. And so that's going to be our, what does that look about 3, negative 3, 0. Okay. So we know it's coming down from here and it's coming down from here. And we know because of the multiplicity of 1, it's coming through those points all the time. Okay, so all we can say is, well, let's say, you know, we come down here. We know it comes down, but we have to come back up here because we have to go through here. I don't know where that's going to flip over, but it's going to flip over. And it's going to come through here, have that linear part here because of multiplicity of 1. And, you know, that's where it was supposed to come through. And then it's going to come back down through here again. So it means it has to flip over pretty quick and then go all the way down. Okay. And again, so this is my general statement for what I'm going to draw for this sketch. Now, is that what it looks like? You know, it's probably a little bit different as far as the shape overall, but I'm thinking we are probably doing pretty good here. So let's type it in. So we have a negative 2x times x minus 1 times x plus 3. And again, hopefully the graph will work. Yeah, so it came down, and that's our point there. That's our negative 3, 0. Comes down here. We didn't know where it turned around, but we said it came around, turned around, and then it went through the 0, 0, and then it came up, and we knew it turned pretty close because then it had to go back down through that 1, 0, and then continue down. Okay, so far, you know, we're doing pretty good. We're matching what it says. So let's pause there, and we'll be back.